Well, welcome to another edition of your math class. We are moving on to Unit 6, starting with Lessons 1 and 2 today. Graphing for the most part, and we're going to talk about functions. So let's see what our goals are. Graph an equation using the point plotting method. Sounds complicated, but really it isn't. Determine if a graph represents a function. Important stuff, but easy. Okay, so plotting points. First, I want you to watch this little video that will entertain you, amuse you, and hopefully educate you all at the same time. Make sure you're listening carefully because I do have some questions that you will see the answers for, so be paying attention. Okay, now that you've seen the video, in the video, what did they call the center of the graph? And in the video, which direction did they always go first? Highly important when graphing points. Right, now that you're experts on smoosh calendar ways of graphing, really weird video, right? We're going to use equations to create pairs of coordinates to find locations of points. Now this is how we're going to come up with points to graph, okay? I know this looks weird. There we go. We've got this equation sitting there, and then on top of it we've got a table, and I've already started the table for us, haven't I? Here's what's the deal. We're going to take these values for x, and we're going to plug them into our little equation here and come up with what y would equal when x equals certain things. X is a very independent sort, and it can be any number here. Okay, any number you want. You could have put any number there you want at all. I could have put lots of other numbers there besides 0, 1, 2, 3, but you know me, I like to work smarter, not harder. I chose the easy ones. Okay, 0 is always an easy one. I always love to start with 0. I always plug 0 in just to see what happens. Okay, so if we put 0 in, 0 plus 4 is only 4, right? 1 plus 4 is 5. 2 plus 4, 6. 3 plus 4 is 7. Easy. I know you're thinking, boy, that's got to be hard, but no, it's really not. So I want you to see if we plug in 4 for this little equation, okay, what is the coordinate set if x equals 4? I know it sounds complicated because I said, what is the coordinate set of the equation? Woohoo! Lots of math terms, but don't let it scare you. It's as simply as plug 4 in for x. What do you get? Now, of course, yes, we are looking for a coordinate set. And before you can answer the question, you got to know the right order, don't you? The right order is x always comes first in these coordinate sets, okay? X, comma, y. Okay, now that you're an expert on that, let's go back to our original graph that we were going to do. Now we can graph these points. See, we've got 0, 4 for the first coordinate set. 0, 4. We're actually going to start here at the 0. You know that's called the origin, right? And we're going to climb up, okay? We're going to climb up till we get to 4. So start here. 0, 1, 2, 3, 4. Now the reason I'm doing it right here on the y coordinates, and on the y axis I mean, is because x is 0, so we don't go left or right. We just stay here and go up. Now for 1, 5, we go over 1 and up 5. Since that's 4, I know I can just go one more, okay? And 2, 6 is our next one, over 2 and up 6. Over 3, okay? We're always going to go left or right first, okay? Always left or right first, and then up. And one of my students a couple years ago said that they heard a really good explanation on how to remember which one goes first. Okay, when you are gonna, let's say you're getting into a building. Maybe you guys live in an apartment building. Okay, you got to take the elevator to get to your apartment, right? You're going to step into the elevator. You can't even see my hands, right? You're going to step into the elevator before you go up. Okay, we're going to walk and then go up. If you're going to use stairs, you're going to step and then go up. Okay, so we got to step out, that's left or right in this case, and then we go up. Okay, we decide how far we're going to go left or right, then we go up. So our last set was over 3. 1, 2, 3, and up 4. No, 7. 7, sorry. Where was I getting 4? I don't even know. Anyway, once you've got at least, you need 2 points to make a line, but you should always have at least a third one. So don't, I know I like shortcuts, and 2 would be a shortcut, but you might end up getting it wrong. And if you end up with something weird looking on your graph, like, let's say we had graph here, and okay, this was our second point, and then all of a sudden you've got a point here, and you're supposed to draw a line with that? You can't draw a line with that. So, you know, always go for at least 3, all right? Now, we're going to draw a line now, of course, because I don't have my line tool like we do in Blackboard. There we go. That's not bad for freehand. Now, remember, this goes on forever, so you're going to see me put arrows on them, okay? Simple. Simple. Now, here's one with more than one step. What is that extra step? Well, we're multiplying a 3 times the x. That's it. It's really not hard. So plug in our 0 again. You see that? I like to choose the same things. I'm so boring sometimes. 3 times 0 is 0. Add a 2, we get a 2. 3 times 1 is 3. 3 plus 2 is 5. See how easy this is? 2 times 3 is 6. 6 plus 2 is 8. I'm having to think. You guys aren't here for me. 3 times 3 is 9. Plus 2 is 11. Now, I'm just going to do 3 of them this time, okay? I'm going to start with the 0, 2. Remember, x direction first. This is our x-axis. This is our y-axis. We're going to go the x direction first, which in this case is 0. And then we're going to go up 2. There we go. I'm going to move on to the 2, 8. Okay, I'm just going to skip the 1, 5. I'm going to do the 2, 8. So we go over to 2, up 8. Let's see, that's 4, 5, 6, 7, 8. Whoa, I think we're going to go off the grid with the 11, aren't we? Yeah, we are. Maybe we should do the 1, 5. All right. Because let me see, 11, let's see if that's 8. Although, wait, that would be 12, right? Okay, we can do this. 3, 11, 1, 2, 3, and let's see, 8, 9, 10, 11. Oh, we can't make it. Oh, all right, just does it. Now, the line is going to be a harder one for me to draw because freehand is really not easy. You really want to use a ruler or a straight line tool. There we go. There's our line. And if we double check, that 1, 5 should go in there. 1. Over here, 1, and then up 5. 1, 2, 3, 4, 5. Yeah, well, you can see how crooked my line is. That's where it is. Okay, so our graph's functions. Well, do you know what a function is? Probably not. Let's talk about functions. By the way, these 2 graphs are functions, but we'll explain more in a minute. Functions are simply you put stuff in to get stuff out. Okay? We have an input, we have an output. It's a fancy word for that. I mean, anything could be in the middle of this. Okay? Anything at all. Let me show you what I mean. A function could just add 5 to x. So as you can see, I've got my little drawing here of a function. Where did my pointer go? There it is. You can see I have the little drawing. Oh, my pointer does not want to cooperate. There we go. We got the x going in, adding 5 to it, and the output is our y. Here's our equation, okay? A function has a rule. Okay, this is a rule you got to remember, and you don't need to remember it exactly word for word as it is here. So let me paraphrase it, we call that, all right? It is a relationship between x and y where x value, each x value, okay, each x value has only one y value, okay? So every time we put a 1 in for x here, we get a 6 for y. We don't get 6 and 12 and, you know, something else. We get one value. That's the important thing. Every x value has only one y result. Now, let me show you how this looks. Okay? When we're graphing them, and we're not going to be doing the fancy ones, all right? We're sticking with lines for now, but when you see a graph, and we're gonna just throw some at you like this, okay? There's a test when you're looking at the graph of a function or graphs to decide if they're a function. There's a test to decide. Notice that red line on both of those. Okay, notice the red line. It's called a vertical line test. You throw a vertical line on there, and if it can only go through one spot on your graphing line, whatever the shape is, whether it's a squiggle or whatever, if you only go through one place where you get one y value, then you're a function. Okay, so that's why the one on the left there is a function. The one on the right, notice there is a spot where we can get how many? 3 different y values. Okay, 3 different y values going, 3 different x values for the same y. Okay, 3 different x values for the same y. All right, if I plug in a negative, it looks like maybe a -2, I get whatever that is, -5y. If I plug in a 0, if I plug in, okay, so if I plug in these different x values, I get the same y. That's not work. That doesn't work, okay? Each x has to have one y of its own. Let's take a look at some more. Notice the dotted line this time is our vertical line test. Okay, notice we have the red one there on the one on the left there. It's a horizontal line. Okay, very horizontal, very flat. No problem. You do the vertical line test. Every time we plug in a value for x, we only get one value for y. On the right, it's a diagonal line. Only one value for y when we do the vertical line test. Let's take a look. Now what happens here? If we do a vertical line test, we get all those values, don't we? They don't work. This is not a function. And take a look at Kermit's picture here too. No matter where we put it on him, he's not a function either. Okay, I know that was silly. Take a look at these. These are some more nicely curved lines, but notice no matter where we put a vertical line on them, they are a function. Okay, so now you know how to identify whether or not something is a function. The vertical line, okay, you just put that up there. As long as it only goes through one spot of your graph, whatever the picture looks like, you're a function. So, oh wait, we do have this weird one. What happens when that happens? Now, I want you to notice very carefully here. This has a dot. That means it includes this value. This one is open. It means it does not include this value. So a vertical line, no matter where we put it on this graph, will only have one value for y. Okay? Or we'll only go through our line once. I'm sorry. Only go through our line once. Because if this was a solid dot, then this would be, we'd have 2 values. Okay? We would have 2 values for x, for this y. But no, there's 2 values for y because of this x. I just always want to mix it up. But because it's an open dot, that one is also a function, believe it or not. So the line doesn't even have to necessarily be connected. Wow, crazy. All right, question for you. This is definitely not a function, all right? I'm just telling you. But which of those, the green one, okay, the A, B, or C, which of those lines, those vertical lines test, prove it's not a function? Okay, so fill in the blank. To make this true, blank graphs of curved lines are function. How many? All of them? Maybe. Some? None? Which vertical line test proves the graph is not a function? You can do this. And last question. Complete this sentence by choosing the correct definition of functions. Look it up if you're not sure, okay? This is not graded. All right, how'd you do? So, are you confident in graphing equations? How about figuring out if something is a function? I think you can do this. I hope you feel good about this lesson. We're going to do some practice work now.